Hi everyone, and welcome to another edition of our UQ SFP chapter seminar. In this opportunity, we'll be featuring Professor Andrea Frangi, who is a professor for timber structures at the Institute of Structural Engineering at ETH Zurich. He holds a PhD in civil engineering from ETH Zurich, where he's a professor of timber structures since 2010. He has over 20 years of experience in structural engineering, especially in timber engineering and fire safety. He's the vice chairman of TC 250 SC5 Eurocode 5 in timber structures, the chairman of TC 250 Eurocode 5 in timber structures working group, and a member of the TC 250 HGF horizontal group fire. So we are pleased and honored to have you as a speaker. Just a couple of things for housekeeping. Please try to keep your mic muted. We will take care of that as well. We're going to have a presentation from Professor Frangi, followed up by a question and answer session. Also, feel free to type in any question. We will collect them in the chat and we will transfer them to Professor Frangi at the end of the seminar. So with no further to say, the floor is yours.
Thank you very much, Julian, for the kind introduction and for the kind invitation. Wow, so many people on Friday afternoon. Thank you very much. I see also very nice people, colleagues, friends, Andy, Anthony, Colin, so welcome. I will try to give you an overview about the Eurocode 5 revision, which is ongoing. So feel free to use maybe also this knowledge, but there is always this disclaimer, the Eurocode is on the revision. I will try to give you already some highlights about this revision. If you want to use really the new Eurocode, unfortunately, you still have to wait a few years more. The publication will be around 25, but a lot of work has already been done, so I can present you some highlights of this revision. What are Eurocodes? Are standard for the design of buildings, bridges, infrastructure used in Europe. The Eurocode are managed by this so-called Technical Committee 250, which is then organized with different subcommittee, 10, 1, 2, 3, 4, 5, and so on, dealing with basis of design, action, and different material, concrete, steel, composite. And I'm working in the so-called subcommittee SC5 related to timber. There are also some special working group on special topic. There are also so-called horizontal group. I'm also involved, for example, in the horizontal group fire. This is not the actual spreading of corona, it's the use of the Eurocode, of course, mainly in Europe. You see the blue country using Eurocode. But I think the Eurocode is a successful story of standardization. There are also other countries who are maybe willing to use the Eurocode, other country who has adopted. And I think that, of course, also other countries, North America, Canada, also Australia, New Zealand, you have your own national code. But I mean, we always try also to harmonize and see how other codes are written. At the end, it would be nice to have a code which are harmonized as much as possible, because I think we want to build in a safe and in an economic way all over the world. All Eurocode are on the revision. It's the largest project. The first generation of the Eurocode is dated around 2000, so 20 years old are the Eurocode, and then this was the reason to start the revision, to the preparation of the second generation of the Eurocode. And the Eurocode 5 for the design of timber structure for file is done by a so-called project team. You see here the member of this project team. It was a pleasure for me to chair this small group. We are 5 people that we are trying. We started in June 2018, and after 3 years, after issuing different drafts, we submit the final draft of the Eurocode for the design of timber structure in the file situation. You may maybe recognize and know also this member of the project team. Today I will try to show you the highlights, but there will be also a background document. So we are trying also to document very well all equations that we have in the Eurocode in the future, because I think it's also very important also for the next revision that it will happen in 20 years, but I think it's important to show exactly the background of the content. We got this goal for this technical revision. For example, we should try to avoid having maybe 2 models. Engineers are so good, they always find maybe a better model, but a standard should only give 1 model. And the best would be maybe a simple model so that you can design most of the building with this model. In the current Eurocode, we have also many annexes which are informative, and the goal was really to move in the main part to make them normative. And if you open the current Eurocode, you will not find anything about CLT, cross-laminated timber, about the timber concrete composite. The part dedicated to connection, it does not have so many rules, need improvement. Also failure of claddings, there are no rules. Separating function, there is an annex informative, but actually cannot be used, is more a black box, and most of the country did not accept. So we got a clear objective, and we try to really improve the current Eurocode. Just to give you some number, when you write the standard, it takes time, and it takes time because you have to go through different process, preparing the different draft, and the different draft are discussed in the national body. You get always feedback, and you try to improve the text. So at the end, the final draft, when we submitted the final draft, this was on my computer, the version 81, just to give you, so we have produced 81 version. And with 150 page, more or less, the content, 100 page, the main part, and 50 the annexes. And you see that during this year, we got many comments, and this is very important because the standard should be reach all people, should be really useful for engineers, and we need consensus about what we have written. So, and consensus need a lot of time for discussion and so on. This slide show you that the current Eurocode has only 50 pages, the new one is 100, the main part. And maybe you are disappointed because, again, oh my God, it's so long document. But I have to say that we really try to improve and also to fill some gaps. So we have more about mechanical resistance because we are now also covering more elements. For example, CLT, timber concrete composite. We have more about connection, but connection is very important in timber engineering. And you see also For the non-standard file design, we have substantially increased the content because we have now more knowledge that can be interesting for engineers in the practice. The principle of this revision for all Eurocode was stated in this way. We want or we have to introduce the current state of the art. And I'm also an academic, and we should always pay attention. Current state of the art is not a state of the research. I mean, the research, we are always a step forward, but it does not mean that we have to immediately implement in a standard. Maybe it takes some time. Easy of use was the most important criteria. The engineer should be able to use this document. Avoiding parallel design method, I already mentioned. Similar style between different Eurocode. Eurocode is a success story because it's a package. And if we write all Eurocode in the same way, the engineer can work much better with this standard. And the motto was really evolution, not revolution. Of course, you will maybe do tabula rasa, but it is important that Eurocode evolve and avoiding revolution. This is the table of content. The first 4 chapters are really similar to all Eurocode for the file design of the different material. So you always have the same, and also this chapter, at least the title is always the same, so that the engineer know, oh, tabulated data, chapter 6 in all Eurocode. But this is really also sometimes basis of design is exactly the same word in all Eurocode because it's independent of the material. And then we have the specific part, in our case for timber, material property. There you will find all information, start with sharing, failure time of protection, charring rate, and so on. And then we have this 3 level of designing buildings and so on with a simple table, with simplified method and with advanced methods, connection, detailing, and the annexes. I think it was a nice decision a few years ago during the horizontal group 5 really to decide to have in all Eurocode this 3 level of designing, and the engineer will choose based on the project they are dealing. Maybe it's no problem. I can do the design. I open the Eurocode. I take the value from a table, or I do simple calculation, or sometimes I have maybe to go really for a more advanced. And you will find in the new Eurocode information for all this design typology. And of course, when you are here on 6, it's easy. Sometimes it's conservative, but straightforward. And if you are here, of course, it's more complex, but you expect that you maybe can analyze a little more accurate, but maybe you need also a higher education, because then you have to do maybe a thermal analysis, a mechanical analysis in fire, and of course, this is not maybe an easy task, but you will get information on all this design method. Annexes, 50 pages of annexes. Today, I will just give you few information on A and B. We need these annexes just to be sure that you can really work with the document. For example, in the Eurocode, we distinguish bond line integrity, maintain or not maintain. And the engineer, they have to know which model should I use. And we introduce a simple assessment method so that you can, actually, you will not do this work. The company producing the adhesive, they have to do this test, and then they will declare, okay, bond line integrity, yes or no, and the engineer can use the right model. So this is, for example, an important annex. But we need this annex in order that really we don't give only maybe a question, but we give a close package so that you can really eye-open work in the future. Starting with material property in the Eurocode, for all material, we always calculate the material property, the design value for strength stiffener for the fire situation, starting from the characteristic value, and then we have some modification factor that I explain you very quickly. We have this KFV value, which is a strange factor, but which allow us to go from the 5% fractile value to the 20% fractile value. It's something special that we have only in timber engineering, in the file design. It was also questioned because we don't have this 20% fractile value in concrete, in steel. And based on the PhD of Reto Farni here at ETH, we have really now a scientific basis to show, to demonstrate that for the file situation, for timber structure, we can go for a 20% fractile value based on a code calibration. The partial safety factor, this gamma M, is equal for all material to 1, so you can already forget. And then, of course, where is the influence of the temperature is this K theta. And with this, we consider the reduction of strength and stiffness when timber is exposed to high temperature. You get it, for example, this figure. This is already included in the core in Eurocode. The reduction of compression, tension, shear strength as a function of the temperature. But this figure is included, for example, in chapter 8, where you will do some advanced calculation, thermal mechanical analysis. Usually, when you do the simple calculation based on the so-called effective cross-section method, the K theta is always equal to 1 because we use the so-called zero strength layer in order to do the calculation again very easily. Already mentioned the partial factor always equal to 1. Charring, of course, in timber engineering, you know, I really think that the most important step is the estimation, is a good estimation of the residual cross-section, what I have during the fire in terms of residual cross-section. And in the Eurocode, we really try to have, I think, a good European charring model. We don't want to be arrogant, but we call this European charring model just to avoid, sometimes you have the, maybe you take maybe from one code a piece, then you take another code and you take another equation, and you know that mixing the code, you have to pay attention because the code are calibrated, are organized in a package, and we want to just say, use the Eurocode, but really stay in the Eurocode framework. Use the European charring model, which is something that you find in all countries. You calculate the charring depth based on the charring rate times the time. And in the European charring model, we assume a linear relationship. So the charring rate is constant, however, between different charring phase. So you have different charring phase to consider, and during these charring phases, you can assume a constant charring rate. And then, of course, if you have a member which go through different charring phase, you just go through the different charring phase and you can calculate the charring depth in a very simple way. You need this notional charring rate, beta n. And for this, we have tried to really show, this is maybe a little scary when you see this table. So many factors influence the charring rate. But these factors are already present now in the current Eurocode, however, spread through the document. And what we have done just in one table, we show all influence parameters, we explain the meaning, and we give a clear reference. You get a value from this clause and so on. Meaning that starting from the basic charring rate, you have to consider the modification factor. And now you have the impression so many factors, but at the end of the day, most of the factors are equal to 1, and the calculation is not so complicated as maybe you have now when you see this table. The basic Charring rate at B0, so you need the B0 and then you consider the different modification factor. And the basic design Charring rate is now also in a systematic way presented in this table. Few value for timber member, we distinguish between softwood and hardwood, and for panel. And you see the value range in this range of 0.65 up to 1 millimeter. More or less, you have the same value in all standard. And then, for example, when you now really go to the next step and you consider initially unprotected site of timber member, and you have this long equation, but as I already mentioned, at the end of the day, for linear member, solid timber, you end up with a 0.8 and glulam 0.7. And this is exactly what we have today. Nothing new. And for plain member, you have, again, 0.65, or if you have gaps, you have a little higher Charring rate. This is for initially unprotected, and for initially protected site of timber member, we really distinguish different Charring phase. I think it's very nice, the systematic. I mean, I like the systematic that we have in Eurocode. We distinguish the so-called encapsulated phase, protected Charring phase, post-protected Charring phase, consolidated Charring phase. We give also a number, phase 0, 1, 2, 3, and 4. And in the document, we always refer to phase 3, to phase 2, and so on. And we have introduced we have really refined all figure, because we think the figure are so important, and people, of course, look at the figure. You see that we have the different figure for the different situation. Initially unprotected, here initially protected with different situation. The protected phase, the consolidated phase, the protected phase, the post-protected phase, the consolidated phase. And you see that during the Charring phase, you have a constant Charring rate, but the Charring rate is different. And for example, from phase 3, when the fire protection system fall off, for example, you have an increased Charring rate, which is exactly twice the value that you have during the normal Charring phase. And again, it's just a question of using the document. We think that it's pretty easy to distinguish the different Charring phase and to calculate the residual cross-section. What we have introduced is, of course, the topic about falling off of Charring layer, debonding, delamination. There are so many wording for this phenomena that we discovered already maybe 15 years ago. Sometimes there are things that we do not understand exactly, but we know that this can happen. And now we have really two different modeling, what we call the bond line integrity maintain, as I showed previously. And if you know that the bond line integrity is non-maintain, meaning that you expect this falling off of Charring layer, you use this kind of calculation, which is similar to the previous, but you have the different Charring phase within one layer. So maybe if you look at this figure, this is for protected, for example, CLT, then you have the starting of Charring. This is the protected phase, the failure of the fire protection system. You have the increased Charring rate, then you have, when you have enough charcoal, a consolidated, and here you reach now with the char layer, the first bond line. And in this moment, we assume, okay, falling off, and you start again, increase Charring rate, consolidated, increase, consolidated. Maybe some of you have already seen this in many publications. We call the step model, because you have increase, a normal increase, normal Charring rate. And we give really this in a systematic way. The only thing the engineer should know at the end of the day, which model should I use, the previous or this one. And for this, we give the Annex B. to assess the bonding. For these different phases, you have the different factor. This is the protected phase, so we have a reduced Charring rate. You can calculate for the different file protection system with this simple equation as a function of the thickness of the panel. The so-called post-protected charring phase, when timber is exposed to high temperature, you don't have the charcoal protecting timber. We have the increased charring rate, you see the factor 2, and then when you have enough charcoal, you can go back to the normal charring rate, and the factor is equal to 1. Now you need this value, start of charring, the failure time of your protection system, when you go back to the normal charring rate, TCH, TFPR, TA, and for this, for the calculation of the start of charring, you go back to the separating function method. So we have the link between effective cross-section method, separating function method, and you are able to calculate the start of charring with, again, a pretty relative simple equation. This was already included in the current Eurocode, but again, now we have the link between two methods, the separating function method and the effective cross-section method. Now, the most important value is the failure time of your file protection system, which is absolutely not so easy to calculate. Usually you do some test and or producer give you this value. We know that the failure can be due to a failure of the fastener, but this can be avoided if you have enough penetration of your fastener. We give some rule so that at the end the failure should be due to the mechanical degradation of the material. And for this, I think this is a huge improvement. I think we have, based on a huge database during the last 20 years, so many testing. This was especially our use, collecting data, evaluating all this data. We give some generic equation based on 20% fractal value for the different typical file protection system using gypsum plasterboard, using gypsum fiberboard, 1 layer, 2 layer, and so on. For vertical position, walls, for horizontal position, floors, you have all this equation. If you know the thickness of your layer, you can estimate the failure time. Of course, that maybe a company will say, my product is better, they can do the test, and they can declare always a better value. This is the reason because we have decided we stay at the 20% fractal value, because you can at least do a calculation, and later on, maybe you know, okay, this is product produced by this company, you can have maybe a better value. But I think we feel in this way also an important gap. Here an example also to show you also the scatter of value. It's because you have also some, I mean, you have product on the market which are produced according to European standard, but they don't give always the same value. We have a scatter that we have to consider in this generic equation, and we do just by doing the best fitting at the 20% fractal value. I skip this. It's an easy equation to calculate also when you go back to the normal when you go back to the normal charring rate. Sorry. Now, tabulated data, I already mentioned, we include also tabulated data, and this should be really helping the engineer, because I've sometimes to find and to calculate also the start time of charring, you have to do some calculation. And we have decided to give really some data so that you don't have to calculate. For example, as already mentioned, the start time of charring and the failure time of the file protection system. We try, I mean, we know at least in Europe the typical combination that we have for the file protection system, gypsum plasterboard, type A, type F, or gypsum fiberboard, 1 layer, 2 layer, the typical thickness. And we have already calculated for you. You pick up the table and you have start time of charring, failure time, and you have already your important value to do the design. Or, for example, of course, we know again, based on testing and so on, if you have this thickness, you have 30 minutes fire resistant, 60 minutes fire resistant, ISO standard fire exposure, and so on. We give also this kind of table so that if you have a solid wood panel, 20 millimeter thickness, you have already used half hour fire resistant based on standard fire exposure. Also, this should be help a little for normal cases to do the design in a fast way. And for CLT, due to the transversal and longitudinal layer, it's the calculation of CLT a little more complicated as for solid timber. And again, this was really this, let's say, working together with the industry. We asked the industry, the big company in Europe, which are your most used layout. And they give us this typical layout for CLT. And for this, of course, if you have another, you have to calculate, but at least for this, you find all this table for walls, for floors, initially protected, initially unprotected, and you get that zero strength layer without doing any calculation. You calculate then your charring depth, you add your zero strength layer, and you have your effective cross-section. So it's again, it's an attempt to help the engineers. Then, of course, the chapter 7 is also very an important chapter, is the simplified design method, what probably you use as in the most cases with the effective cross-section and with the separating function method. Effective cross-section method is something that most of you know. We calculate the char depth, we add the zero strength layer, you get in this way the effective cross-section, and by adding the zero strength layer, we assume that we can use now the material property for the effective cross-section as by normal temperature. Again, engineers do a bending verification as they are doing by normal temperature, assuming, however, an effective cross-section. This is, of course, one-dimensional, more dimensional, calculating the char, adding zero strength layer, getting the effective, then the effective cross-section. But of course, you will do now this calculation for the different charring phases, assuming a constant charring rate. And if you go really to the linear timber member, meaning columns, beams, then the long equation at the end are very simple. So this is for the initially unprotected, this is for the initially protected, with the phase 0, 2, 3, and 4. And here you see the equation for the calculation of the notional charring rate with the factor 2 for phase 3, no factor for the phase 4. Here you can reduce the charring rate, and you have all these simple equation. Then this is the long story about the zero strength layer, because you may know we are using the magic number 7 millimeter in Eurocode. We are also abusing about this number, so we are using for all kinds of situations, even if we know that the 7 millimeter was established many years ago by Schaffer and so on, and this was for bending. I mean, there is the full story. And we know during the last, I have to say now 15 years, that 7 millimeter is not very conservative. It's actually non-conservative, especially if you have a member under compression, and we increase the value up to 40 millimeter for compression, and for bending foundation we can use a lower value in the range of 10 millimeter. Of course, that many engineers are disappointed, but in most of the cases you have no consequence. Also, if you have designed building in the past with 7, you will not demolish and rebuild. But it's our also duty after 20 years to go through the current model in a critical way. And if we think we have to adjust the value also in the other direction, meaning increasing, we have to do. This is our duty, and we have done also this. For plain timber member, again, the initially unprotected, the initially protected equation, which are again very simple. Here you have this factor for gaps and so on. Usually it's equal to 1, but if you know that you have really a gap more than 2 millimeters in a systematic way, we know that the charring rate increase a little in the range of 20%, and you should use also this gap factor. And then, of course, I can do this very quickly. You distinguish bone line integrity from the case bone line integrity non-maintained with the stepper model for the different layer. And this is usually used for CLT when you expect this falling off of the charring layer. Zero strength layer, easy to calculate, usually a function of the thickness of the member. Here, the table for solid wood, glulam, and LVL. And for CLT, again, CLT is a nice product, but it's a little more complicated due to the longitudinal and transversal layer. We give separate table for floors. But if you look at the value, just the range of order, we go from 7 to 16 millimeter is the range of order for the zero strength layer for CLT, for floors in this case, and then you will find the table for the walls. The calculation is, you have to do the first time. This is the reason that we have also introduced the tabulated data, because you know, the first time that you open and you start the calculation, you have to understand the model, but there will be also, as I mentioned, background document, and there are already now many, let's say, publications showing the background for the calculation of CLT. Timber frame assembly, so joist stud and then panels, we extend, we are able really to cover the full insulated cavity, the partially cavity, the void cavity, or when you have the insulation only on the side of the member. So you can design all the situation with the new Eurocode. And you can consider all insulation. So this is again a huge improvement. At the moment, you can only consider stone wool. In the future, you can consider any kind of insulation. But of course, we know that the insulation show a different material behavior, and we distinguish 3 different protection levels, PL1, 2, 3. 1, let's say, is the best performance, a typical stone wool. And 3, you see the insulation that are in this category, insulation that start disappearing already at a low temperature. And again, the question is, what is the performance? We give already this table, so that you know already which model you have to use with PL1, 2, and 3. But if a producer saying, oh, sorry, I disagree, my insulation is much better, they can again go to this Annex B, do a test, and demonstrate that the insulation perform in a better way. When you have stone wool, the protection level, the best protection level, we really assume no charring from the lateral side. We have the zero strength layer on 3 sides, but otherwise there is charring only from below, because we assume stone wool is able to protect the member from the lateral side. And there are the equation. We give the zero strength layer, again, usually just a function of the geometry of the member. And then we have also the figure showing what happened with protection level 2 and 3 and for void cavity. And what happened is that you have to assume also a charring from the lateral side, not only from, let's say, below. And here we give also when you have to consider. So there is a moment where also the lateral side is exposed to fire, and then you have to consider the charring from the lateral side. Depend on the so-called recession speed of the insulation, how the insulation react. We have this value now for for glass wool, for wood fiber, for cellulose. So we can really consider also this kind of insulation, which I think is good because any kind of insulation has the right maybe or the right application, and you can consider also for the fire situation. Of course, you have to design sometimes also the timber panel of timber frame assembly. If they are load bearing, there are enough rule. And here, at least for this, we go back to our magic number 7 millimeter is still okay for this calculation. Separating function, I think this is very nice that you can verify EI criteria without doing test. You really can calculate any kind of walls and floor with the separating function method, which is an additive method. So you calculate the contribution for the different layer. This is already based on a PhD done many, many years ago here by Vanessa Schleifer, and you see 2009. And this is also the idea. I mean, this method has been used now for 10 years, 11 years in most of European countries. And we know that it's working. We have good experience. There are no tests showing that the model give a completely wrong results. So you calculate the protection time for the different layer, and the sum is just your fire resistance of the blue floor or of the wall. And of course, you have a so-called basic protection time, and then you consider also where is the position of the layer, because if it is exposed from the beginning, behave in a different way. If the layer is in the position number 3 and it is exposed to fire later on, then it will also burn faster and so on. So we consider with this position coefficient for the exposed, unexposed side. And then we have this maybe strange delta T is really a bonus for a fire protection system which stay longer, so that they don't fall off immediately when you reach about 300 degrees behind the fire protection system, by protect the next layer longer, and which is good. And we want really to consider with this delta T additional time. And we have now, again, equations which are not so complicated. Even if you look at the equation, you think, what does it mean? But when you start working with the model, it is pretty easy to calculate also this delta T. And this is now done as also in a systematic way that you will understand the physical idea behind this delta T. And the good thing is that, I mean, we have more or less the value for, I cannot say all material, but most of the material that you use at the moment, you will find the value, so that you can really more or less estimate EI criteria, verify EI criteria for most of walls and floor that we are using. Of course, you have to fulfill also detailing. So maybe already one question will be, yes, but this is more a checking of the thermal insulation. What about the integrity? The integrity is covered by respecting clearly detailing, because you know that fastening is also very important for this falling off. So you have to fulfill some criteria with regard to detailing. We were able, based on many tests, to extend up to 2 hours. So we are really extending the calculation model for a longer fire exposure. So we go from 60 meters to 2 hours. Connection, there are no timber building without connection. Again, here we have the first improvement. We are able to extend the calculation up to 2 hours. We have enough experimental data. And we have 3 levels of calculation. There are simple tables. You get a minimal fire resistance, but usually this is in the range of 50 minutes, so not interesting. And then the next level that we have introduced, just checking the geometry of your member. So we give for a typical, for example, here, steel to timber connection with 2 slotting steel plates. We give here the timber cover, this T1, and this the thickness of the timber side member here. And we see, okay, for 30 minutes, you need maybe 50 millimeter. If you need 2 hours, you need more timber, 140 millimeters. So you are not doing any calculation, you just check that you have enough timber around your connection. It's like a tabulated data, but this is included in the chapter 9. And we have done this in a systematic way for typical connections, a timber-timber connection, steel-to-timber connection with slot in steel plates. Then, of course, you can also calculate for any kind of connection. And we have this is already included in the current Eurocode, but this was improved based on many test data, the so-called exponential reduction method. So the load carrying capacity is a function of the time, and during the fire exposure, you lose some resistance or load carrying capacity. This is approximated with an exponential function. And now we have, however, better data so that we can design connection with nail and screw, and especially for dowels and bolts, not to dowels and bolts, sorry. We have now an improved design model which allow us to go up to 2 hours. You have, however, also the possibility to protect. So we give also a rule. You can also have longer fire resistance by protecting the connection, or, as I mentioned, by increasing the dimension. So you will find these two strategies. You can design for half hour and then protect. You can design for half hour and increase in the dimension to get maybe 60 minutes, 90 minutes, 120 minutes. Then there are also some information for external steel plate, axle loaded fastener, and also carpentry connection are covered in the future Eurocode. Detailing very quickly, of course, is very important, and we extend. I mean, the current Eurocode has 2 pages. Now we have 7, but because it's also very important to describe how you have to fix the panel, how you have maybe to deal with penetration, with opening, with joints. You know that the fire is going through this weak point. So we try to give advices, rule. Most of these rules are permission because maybe there is a better solution, but at least we give some information, and especially in order to use the previous modeling, it's important that you respect. So you will find also some information about supporting area that you have to check, of course, that your member will not start falling down. You have this kind of table giving you the spacing for the fastener, for panels, based again on experience, on fire testing, about joints, how you have to deal when you have this joint, and maybe this joint is 4 millimeter and so on. We give some rule up to 5 millimeter. We say, forget, nothing happen. If you have, however, big joints, then you have to assume 2-dimensional charring. So you will find additional information to really be able also to look at the detailing, which is very important for the fire situation. And finally, yeah, the annexes. Now, maybe you are disappointed because the main part, of course, is dedicated to ISO standard fire exposure. We will probably design most of the building according to ISO standard fire exposure, but we know that authority will ask you in the future also for a performance-based design. And this is now everything included in the Annex A, design of timber structure exposed to physical-based design fire. We have really extended, improved, rewritten completely Annex A. And we cannot say that we have already a perfect solution, but I think we are giving now a framework for engineers. Of course, this is already, I would say, for well-educated engineer when you go to a performance-based design, to consider, of course, timber in the building, and to consider what's happened when you have timber exposed to the fire. This is a huge discussion about fire dynamics, tall buildings, and so on. You will find now some simple equation how you can consider the contribution of timber during the fire. This is now we, of course, we look at the knowledge that we have on this. This is already state of the research, and this is the reason that we decided to declare this annex informative, just because we assume it will be improved also in the future, and the national body can maybe also adjust a little. We have considered especially knowledge coming from latest work in Europe by Norman Werther, Joachim Schmidt, by Colin Wade, and so on. And what we recognize in the last year is really that we always focus on timber, charring timber, but for the fire dynamics is important. More important is the char layer, which can be considered like a battery, which is able to store the energy when you convert timber to char, but which is also able to release later on this energy, maybe in the cooling phase and so on. And we try to explain this and to give a framework for the engineer. At the end of the day, you need really some simple equation. You will find first, I mean, I think this is not so straightforward, because to clearly state also in a very simple equation that you have to consider the movable fire load plus now the contribution of timber, the structural fuel, or what we call structural fuel or structural fire load. And the question is how you can calculate the contribution of the structure. And you go back to this equation, the rate of release for the contribution of timber, that is calculated based on the charring rate, which is, however, now, and this is the complicated calculation, is not a value. It's a time dependent, and this is always changing. So the calculation is also an iteration, because you have to calculate the charring depth. With the charring depth, you can calculate the charring rate. You can then calculate the rate of heat release. You can add, and then you repeat the calculation in an iterative way. But in this way, we think that you are able to consider also the contribution of the timber structure. And the alpha factor is exactly this the alpha factor consider this storage effect. Some energy is kept in the char layer and released later. And about this factor, there is ongoing research. Daniel Brandon is showing, based on analysis of huge, large tests done now in North America, is in the range of 0.3, 0.4. We are able to show that the value can be also higher, especially in the cooling phase. At the moment, we just set to 1. Usually in a conservative way. We expect that in the future, we are able to give this value for typical situation. But as I mentioned, here is still ongoing work. The good thing is that until 25, we hope to have also here an improved version of the Annex A. How to calculate the charring depth? Here we go back to the model proposed by Norman Werther, is this cumulative temperature charring model. With this, you can estimate the charring depth. And then, of course, for the design, at the end of the day, we go back to the effective cross-section. And again, the zero strength layer is not anymore a constant value. There is this modification with another factor, alpha Fe, as a function is you are in the fully developed phase, you are in the cooling phase, and so on. we try to give something, and this is, I think, a challenge, but I think it's important to give some advice also to engineer, better than nothing. But of course, I think this is the highest level. There are colleagues saying, please don't do anything in standardization. We understand also this point, but I think to give a framework, to give some advice is already a good thing. And here, however, we expect in the future, of course, possible improvement. Finishing with the Annex B is, some of you already maybe have seen, I think we have been presented also by Structuring Fire. We have this test method, very simple to evaluate the bond line integrity, the idea to have maybe a CLT member and to measure the mass before and the mass after the test. So based on the mass loss, we are able to capture this falling off. And of course, now there is the huge discussion. You have to introduce a threshold when you are good, when you are not good. But I think the test method is very easy to capture this falling off of Charring layer so that in the future you can say, okay, I use model A, I use model B. I'm very sorry, the idea was 45 minutes, now it's 1 hour, but this is my last slide. I hope that you get a feeling about the new Eurocode. We really try to improve the current Eurocode. We have the new European Charring model, which is not completely new, but we try really to have a systematic way to present also the different influence factor and so on. We have, of course, the new information about the failure time of the fire protection system. We have, for the effective cross-section method, I think now we cover more or less the most important timber elements, CLT, timber concrete composite, I didn't mention due to time constraint. We have for timber frame assembly, revised rule. For connection, I think the most important thing is extending the knowledge up to 2 hours. We have revised the important rule for detailing, and we are really working on the topic designing of timber structure based on physically based fire. We have the new Annex A, and this will be, I think, improved again in the next year. Thank you very much. Doing standardization, I know, for example, Andy know exactly what I mean. It takes time. You need a lot of discussion. You need the consensus. So it's really a long journey, but we are happy. We are doing this since 25 years, and we hope that the new generation of the Eurocode, especially also for timber, which will help us also designing these kind of buildings. All and only, I mean, we need timber in buildings also for some climate changes and so on. It's good if we use more timber for buildings, and for this we need also good Eurocode, at least in Europe. Thank you very much for your interest, and sorry for being 50 minutes too long, Julian. Back to you.
Andrea, thank you for your presentation. Really thorough and interesting and full of insight. So we are having some questions from the attendants. I'm going to start by reading some of them. So one of our attendants is wondering if the latest draft of the document is already available as a public document or not?
Yes, yes. The latest draft is available on my computer. At the moment, the latest draft is going in the first informal inquiry. So all national body received the document. We started this last Monday. For 2 months, the national body are commenting. And all members get this document, and national body they can spread. I don't have any problem. If somebody want to have the document, I can give the document in a confidential way. In a way, I mean, the problem if you want to you cannot use. There is no legal basis. That's. I mean, we always say you cannot use. You cannot design unfortunately building based on a draft.
Mm-hmm.
At least you have the full responsibility and authority accept. But on the other side, if more people look at the document, we will identify weak point, and we want to identify weak point. And actually what we want to do is maybe for 1 year before really we go to the final publication, it would be nice if the engineers start doing some calculation, because we need a lot of calculation to understand all weak point. So for Andy, please, we will keep in touch.
Okay, perfect. And related to that issue of oversight and having a small group, one of our attendants, he's wondering what's the role of oversight. It's really impressive, all the progress that you have made considering you're such a small group. And yeah, he's wondering if you could explain a bit more about how the requirements and recommendations are peer-reviewed as the draft progresses.
Yes, thank you, Felix. As I mentioned, the draft in progress follow very clear SEN rule, meaning that you go through different stage. You prepare a first draft, and the first draft goes for commenting through all national body. You have to answer the comment. You prepare the second draft, the same procedure. You prepare a third draft, and you prepare a final draft. And after each draft, you get comment and you have to answer. And we cannot just say decline. We have also to answer why, or what is the reason to say, oh, okay, we think it's good, but we want to keep, and so on. In national body, what does mean? That all country has the mirror committee, UK, Germany, Switzerland, Italy, they receive the document and then they comment. But for example, Felix, for you, for Annex A, we went beyond, because it's really something completely new, and we asked directly people also that we know that work in this area and so on. And we also involved the SC1 subcommittee 1 dedicated to action, because there is this part about the contribution of timbers which could be moved to the Eurocode 1. And we discussed this with colleagues that you know very well, Cephus, Luke, BSB, and so on. So, as I mentioned, at the end, it's very important that we have consensus, and because we want to have also the trust, and we want to give something useful. And if there is no consensus, probably we will just delete. It's meaning it's not mature to have this content. I have to say the main part is very, very well written, and we have 20 years or more along much experience. The Annex A, which is really something new, it's something that which evolve, and this is the reason that we go for an informative. Informative annex mean that the different national body can really say for us is too early. They can just say, we don't use in UK. Or they are saying, maybe we would like, however, to improve this part and so on. So we want to give something, but we cannot say, now you should do like this. I hope I answer your question, Felix. Thank you.
Thank you for your sort of answer. And now moving into more on a side related to the interaction between the timber and some other elements in the construction environment. Brandon is asking if the temperature penetration from contact between the steel connections has been considered in regards to the impact of the charring area, and also a comment on the effectiveness of intumescent coatings.
Yes, yes. The temperature penetration effect is considered, and you will see that we consider, for example, a higher charring rate close to the timber where you have the connection, especially to consider the influence of the slotting steel plates, for example, and steel dowels and balls and so on. So you have a so-called modification factor for the connection, again, a K-con connection, which is in the range of a factor 2. So meaning that due to the steel plates and steel dowel, you increase the charring rate, so you bring more heat into the residual cross-section. We have this increased charring rate is considered in the exponential model, but also in the geometry that we give, in the requirement that we give for the connection. With regard to intumescence painting and so on, I have to say that we are not covering intumescence painting because there is another European standard covering this, actually, that if you have intumescence painting for timber and so on, usually you go through this test and then you can show what is the performance of the intumescence painting. Theoretically, we have the framework, because if I know that the start of charring is delayed by half hour and so on, then I can just, based on this knowledge, use the Eurocode, but we are not really covering, we are not giving also anything, because I think it's product specific.
Right. Thank you for your question, for your answer, sorry. I think the question was addressed, so we can move on to the next, if you like. So one of our colleagues is wondering if you could explain the rationale for using a standard fire exposure for the tabulated and simplified methods, considering that some researchers have questioned its applicability to combustible structures.
Yes, of course, I understand the question, and we are also researchers doing and questioning and introducing also this Annex A, exactly because we know the limits of a design based on standard fire exposure. But fire safety is not just a matter of a calculation, it's just not a matter of combustible material. And at the end of the day, each country will decide how much safety and what are the requirements for building and so on. We want to give to engineer the instrument and to fulfill R60 or to check a burnout. And I don't know. My impression is that we should pay attention, because this is very important. This topic is now really addressed already in the new Eurocode in a way that we think we can. But I hope that nobody wants to design a single family eyes based on a performance-based design. So there are some category of buildings, and when we talk about timber buildings, we talk about a 4-story building, 5-story building. Of course, now we are enthusiastic about tall buildings, but the huge potential in the market is multi-story building, medium-rise building, and for this kind of building, and this is my personal opinion, I'm convinced that you don't need performance-based design. You can have safe building using the normal framework of ISO standard fire exposure. I stop here because we can debate for hours, and please understand me, we want to improve and we are still working. I mean, we finished the PhD of Jochen Schmidt in this area. We are starting a new PhD. We are working all together to improve the knowledge also in this field. But I don't like the idea to say, forget what we have done for the last 100 years, which is still very interesting, important for many, many buildings that we have built in the past and that we build in the future. Fire safety is not just a matter of combustible material. And you are fire safety guys, and you know exactly what I mean. Thank you, Ian. I mean, of course, we can debate, I know, for days, but I'm convinced we are going all together into the same direction. Felix, yes. The comments and answer be published, separated. I have to say that the comments and the answer are in the end of the national body again. If you want to see all comments and all answers, just ask, for example, colleague of UK and so on, or me. You should be member of this national body. Yes, that's they are not published. What we publish in the future, there will be a background document. This should be really available because it's like document produced maybe in cost action or in European project team fix or any kind. This is important to show, yes. If you want to see the single comments and the single answer, this you should go via, again, national body, or you can contact me. Again, it's everything open and transparent. The process, this is the most important thing, is that the process is transparent. And you know, we have 81 versions on my computer because I want to be able to traceable the work during the last 3 years.
Thank you for
this magic alpha factor. It seems like a very arbitrary empirical factor. This kind of something which, it is not arbitrary because there is some physical understanding, but there is no value. The value change, and is empirical because, of course, it's based also on tests and so on. Is there a scientific consensus on this model proposed? Where can one find the publication detailing? Yes, of course. There is slowly a consensus. We will now see the next round of comment publication. I can send you some first publication. If you go to our LinkedIn ETH timber structure and so on, you will find that, for example, there is this publication by Jochen Schmidt about the TIX model and so on. It's already giving you a very good we presented this also in structure in fire and so on, and you have the alpha factor is something that also Colin defined in a different way, Daniel Brandon defined a different way, but I think we have consensus that char layer as a ETH content, which is much higher than timber. Of course, the density is also much lower, and we have now done many tests, and we can quantify the ETH content of char. But this depends also what happened during the fire and so on. and also the density profile of char layer is varying. It is, I think, a very important, interesting research area. And at the moment, we want just to give, as many of you give, first say, pay attention. You have to consider, you have maybe to consider that during the cooling phase, the char layers start oxidizing, that the energy is released again, and so on. And advise how you can maybe do, but this is something that it is the highest level for me, and I think this should be done also by really very good engineers in the practice. And again, probably you will not do for a single family house. You can do, but it's a waste of time, in my opinion.
Okay, thank you, Andrea, for your thorough answers. I think, yeah, that covers everything that all of our attendants.
Colin has already put the link, yes, on the TIX model by.
Perfect.
And maybe for Julian, I'm sorry, but of course, my idea was not to do 45 minutes about Annex A. Annex A is very interesting for this audience. I really invite you to invite your HB to do only one session about this field, which is very, that's
No worries at all. We really appreciate that you take the time for giving this insightful presentation to answer all of the questions in there, maybe not so simple questions. And yeah, as Felix was saying here, it would be amazing to have you here in the next WCT Congress we are going to have here in Brisbane, hopefully, and have more discussions. So a material as interesting as, with so many advantages as timber, can be used safely in the built environment, which is in interest for all of us.
Thank you very much for the kind invitation, interest. If you have more questions, feel free to contact me. Thank you very much. Enjoy the weekend. For you, the weekend already start. And I have to say, we are following also what in Australia happening. And you are also, again, building so many nice timber building, which is fantastic.
It's amazing. Yeah. Thank you, Andrea. And thank you to all of our attendants for coming. Before closing the webinar, I would like to share my screen just for a second. Reminding you, all of you, about our next seminar, which will be held the next Friday, in case you are interested. The event is also in Eventbrite, so feel free to register there. Dr. Erika Kuligowski will be talking about how interdisciplinary research is used as a way to protect people exposed to bushfires, a pretty hot topic recently, not only here in Australia, but also all around the globe. Yeah. And again, thank you for your presentation, Andrea, and thank you to all of our attendees for coming. Have a good one, everyone. Bye.